Finished my undergrad focusing on economics and statistics, and didn't really know exactly what I wanted to do like most people when they finish their undergrad. So I actually got a job at a startup company called Whoosh, which was a startup CPG company that sold like a screen cleaning product for tech devices. And while I was working there, I developed like a sales forecasting predictive model for the team to try to forecast out, what the units sold are going to be in the coming months, so we could plan the supply chain out a little bit better. So with that, that kind of really piqued my interest in predictive modeling. And, I always had a real kind of fascination and love for statistics. So from there, I did my master's in management analytics, as you mentioned. And while doing my master's, I befriended someone in the program that worked at Scotiabank. He let me know about a data scientist position at Scotia. And I applied for the position. Unfortunately enough, I got it. And then, recently was promoted to senior data scientist. So over the past 4 years or so, I was working primarily as a junior data scientist on the team, working on a bunch of different interesting projects at Scotiabank, most of them pertaining to risk predictive modeling. But I got to do some really cool projects in HR as well. So, bunch of different projects that I worked on that led me to the senior data scientist role that I'm at now.
Back when I was in first year, I actually intended to go to university to become an investment banker or a hedge fund analyst, and then work out. So I was okay. Well, I was like doing all these stock pitch contests and all this like research and whatnot. However, like I realized that I'm in data science, or I'm in computer science. So maybe let's try to figure out like what jobs are in like the ballpark of business plus computers, and the answer is data science. So I made my way to the University of Waterloo actually to do a tiny ML project with a club called Coffee and Code. From there, I built a cyberbullying detection engine based off a naive Bayes like ML model, and then I used that to get my first job at CIBC, where I worked as a data scientist intern. And then from there, once you get that inertia, you get that first job, then all the jobs become easier. And then I worked as a machine learning intern at a company called Intact Financial, that is like Bell Direct for people who don't know about that. And then, then from there, I got in, I had a connection at a startup doing research on using Wi-Fi to predict motion. And that was called Cognitive Systems Corporation. So I guess the answer to that question is like, I kind of fell into it. I consider it like a happy accident that I got into data science. So yeah, that's my story.
Number one thing is I've practiced programming a lot. That's really important. Even data structures and algorithms, that's the number one thing for getting a job like at Amazon, is knowing that stuff. Another thing is, I've read a lot of career advice. I've read a lot of people's experiences. I find on Reddit, there's a lot of good communities where people will share information about how to get jobs, like what kind of information you need for internships, stuff like that. You can learn a lot from other experienced people on the internet. Now I'm doing a Master's of Data Science and Artificial Intelligence at UW, and that definitely helped. Like I never got any interviews with any of the big tech companies before I started this Master's. So if you are in that position, that could be really helpful. So I did 2 co-op terms while I was at Laurier doing my undergraduate in computer science. I did a minor in stats and a minor in econ. And I did 2 co-op terms. And one thing I think that helped me is at those co-op terms, I didn't just do the work that I was assigned. I went above and beyond and tried to do extra work, tried to create something that was like really valuable given the position I was in. And my bosses really appreciated that, both jobs, and I got excellent reviews for that. So that was helpful. And then in my 4th year at Laurier, I did the directed research project for both of those semesters. And I found that was really helpful because it allowed me to build a relationship with a prof. And that relationship has been somewhat helpful so far. And it was helpful for getting into UW as well, because I was able to use her as a reference, which is one of the things you need. And then I was also able to do a research internship over this past summer because of that relationship with that prof. And that helped me. I was able to actually get my paper published in a tiny conference. So that was legit. And overall, being able to do research, understanding how to do research, understanding how to read research papers are all really important things and are all really beneficial, even if you're not going into research, if you're not going to academia, if you're going into industry and you want to build things, it's important to be able to understand how other people have built things. And the best way to do that is through reading research papers. I also, always am trying to improve my, mental habits, the way I'm thinking about things, because, the different ways of thinking about things can result in, different levels of effectiveness in terms of achieving your goals. And I also always try to improve my soft skills, like being a good leader and being a good coworker. These are all good ways to impress your coworkers, to network, to build connections and stuff like that.
In high school, I always knew I wanted to, write code for a living. I want to be a programmer, want to be a software engineer. Went to Waterloo because obviously they were advertising, getting all those great internships and co-ops and stuff. And so how I fell into, so for those, I guess none of you know yet, but I'm a software engineer that specializes in data engineering. So literally my job every day is to walk in and make it easier for data scientists to do their job, which means make the data way super accessible, really easy to ingest and perform all kinds of analytics. How I ended up like this, I didn't know what data engineering was going into first year, applying for my first set of co-ops. I basically just applied for a bunch of positions because I was desperately trying to get any co-op at all. I didn't really have a specialty or anything like that. And then I got hired at Kik for my first internship, and it was for a data engineering position. They basically gave me like a high level overview of what data engineering is, what it means, why it's important. And that's where I really got a lot of my experience and my knowledge about what is data engineering. Why is it important? What does it mean to have a data-driven business model? And what role does data science play in all of that? Very important one. So yeah, I basically got a bunch of internships that on data engineering teams at companies that were kind of driving the forefront of this like data-driven idea. Kik was one of those places. I learned a lot there. I started basically specifically applying to jobs that were software engineering positions on a data platform. Worked really hard in those internships to get return offers or, at least build up my resume, build up my skills. And then for my last internship, I worked at Coinbase. The data team there was really new and had like a lot of room for growth, both on data engineering side and data science. And I saw it as an awesome opportunity. So I worked really, really hard during that internship because obviously it was my last one. And I was kind of hoping for a full-time offer. I was just less lucky to get one from them. And I've been working at Coinbase ever since.
A large portion of data science is actually, data engineering work. So I would say if I was to look at my day and break down, my average day my average week over the past 4 years, it would be probably like 70% data engineering, data pipeline work. And then, maybe the remaining percentage doing modeling related work and ad hoc analyses. So, a lot of the focus of our day to day is on doing exactly that, stitching data together, building out the data pipelines, connecting data from different source systems. So I would say in terms of, things that we focus most of our attention on, it would be that. And then in terms of building out a craft, well, I think like the craftsmanship part would be, your programming discipline. So the code that you write. And like Max mentioned, practicing programming on a weekly basis and building out your programming craft that way. I think kind of like data science, it falls under the programming umbrella. And you have to be a good programmer first if you want to actually be a good data scientist that can put models into production. So that's sort of my roundabout answer. I'm not sure in terms of percentage breakdown, but that's kind of how I view things.
Data science is like in practice an interdisciplinary field of statistics, programming, and like some domain knowledge, right? So it's like, I guess that you can teach those things and whatnot, but I guess with any sort of employable skill set, it is in fact like a matter of practice. It is in fact a matter of like, having an understanding of the tools used to conduct this data science thing. So there are programs coming up in data science and machine learning and what have you. And it's like, okay, well, they teach you that, but like it seems to me that data science more so than most other subjects is kind of like a trade school type of thing where like the point of studying data science seems to be to get a job further. I'm not talking about ML, by the way. Like ML is a subject people actually like research and whatnot, but data science as a whole seems to me like at the undergraduate like level to be a trade school type of thing. So because of that, it leads me to believe that it's more so a craft really. Like, and all the new educations or the new like degrees that are coming out are just there to kind of facilitate that, I guess. So once again, like there's no balance really, or there's no like percentage as to how much of data science is a science. to be taught versus a crafted practice. And to get the ML researcher jobs, like to actually like work on these models at a corporate setting, like maybe let's say Google Brain or Facebook AI, you would probably need a PhD. But to do like the other data science adjacent things, you could probably get away with a master's or an undergraduate. In the event that you are undergraduate, and tips I have for you would probably be to do projects, because that is like a lot of the projects that exist mirror actual problems in industry. Like for example, like let's say you do like MNIST or something, which is like classifying handwritten digits. Like CNNs are used in practice like at actual companies. So the skills are definitely transferable. So if I were to say anything, it would be projects. And number two, I would highly recommend you pick up some domain knowledge on something. So my background was in finance and like in investments. So that kind of like yields well for me to work for a financial institution. Not to say that I know anything about like, commercial banking, but like I did like have an adjacency to that field. So that kind of helped me get a job in data science and banking and insurance. So like I highly recommend you kind of build up a domain knowledge of some kind, if that makes sense.
I think in terms of, is it a science? Is it a craft? Like definitely most of data science, in my opinion, is a science. All of the research that you're doing is you're doing hard science, you're doing actual experiments, you learn things definitively. And then there's the aspect of data science, which is data engineering, which is also a science. There's very specific things you can do and you get a specific result. It's deterministic. But then there's the analysis portion of data science. You take your data set and you're trying to not only like, are you trying to do a strict prediction model? You're actually trying to like understand why is this data the way it is? What can we learn from this? What can we use this knowledge that we're learning? How can we use that for our business? And the data scientist ideally needs to not only be able to get the information from the data, but they also need to be able to relay that to management, because management has no idea what's going on. And you need to be able to tell it to them clearly in a way that they can understand. And those two aspects of data analysis are totally about your intuition. They're about your soft skills. It's a craft. It's about practicing. And programming is a craft as well. You have to practice it, but it's definitely both things for sure.
In my experience, the data scientists that have struggled the most that I've worked with are the ones that really were great in terms of stat skills or more data science skills, but they were lacking in their technical skills. And that kind of hindered them from being able to really reach their potential in terms of what they could actually do in terms of analysis. So my 2 cents on this is I know that a lot of data scientists like to just focus on the actual data science and less on, how do I use GitHub and how am I going to commit this code and how do I run tests on my SQL or something like that. And so my 2 cents is you will be a much better data scientist if you take the time and learn the more technical aspects involved, even though you may not want to and they may not be as fun. But yeah.
Literally every department, I think, within the bank uses data science or predictive modeling to some degree or some capacity. Maybe I can expand on some of the recent developments that I've seen, at least within Scotiabank, to give you a sense of the type of projects that are underway at a big financial institution like the bank. So one of the main projects that I'm working on with some individuals in commercial banking and commercial risk is, after COVID hit, there was a real need for the business to understand customers' near-term liquidity and cash flows. So what we're focusing our efforts on over the past year or so is building out a really nice, robust predictive model that takes in data from a bunch of different sources to predict a customer's near-term cash flow, whether that be their cash for the next week, the next month, or the next year. So it's really about bringing in kind of all these different disparate data sources together and making those near-term predictions that the commercial bankers and commercial risk folks would use. So that would be on the commercial banking, like a larger project that's underway. And then, in things like anti-money laundering, AML, you have, advanced predictive models getting put in place to predict fraudulent activity. So looking at things like customers' financial network data to, see if there's any irregularities or outliers in their transactions or in their behavior, and then flagging those customers. So there's some really interesting sort of deep complex ensemble models that are being used there. Those are kind of 2 instances that come to mind, but I'm sure there's definitely more within the financial industry. It's literally affecting every single department within the bank.
I consider myself at this point primarily in the software industry. So I would say the effect of data science on the software industry is huge. What computer scientists and software people are doing these days is totally different because specifically machine learning has really enabled software people to handle a completely new type of problem that traditionally, software people had no idea how to solve. You've got infinite ideas for how to solve it. None of them make sense, but machine learning actually allows you to solve these types of problems. So that's what I'd say about how data science has changed it. Then there are a few other things I want to say. Something that's come up a bunch of times in this conversation already is the different subfields that are emerging as a part of data science. Even as much as few as 3-4 years ago, it seemed like data science as a title was going to be the future. Data scientists were going to be everywhere. There's going to be millions of data science jobs. It's the sexiest job of 2020 or whatever. But that doesn't seem to be the way it's actually going. It's actually fracturing. It's splitting into a lot of really specific jobs. And what I think each of you as undergrads need to do is think about which of these subfields you're most interested in. You don't have to pick one and then just go for it blindly, but you need to start thinking about it. What are you going to do? What skills do you need to acquire to get those jobs? And how are you going to use those skills? And how are you going to gain the leverage you need to convince employers to trust you and to pay you well?
There are tons of aspects of insurance that are modified by data science. Number one is claims. Number two is like actual pricing. And number three is like operational efficiency. So these are all the aspects of insurance that are being impacted by machine learning. I have worked on claims. An example of like how ML changes claims is essentially like in the days of old, when you file a claim, you have all these forms, and then these forms get evaluated by an adjuster. And then let's say, for example, this adjuster like does all of your analysis for you, and then like puts all the claims into its appropriate buckets. CNNs can now do that. Can now just like render those jobs like obsolete, and insurance companies really like that, because like the whole purpose of insurance is to kind of like file a claim if you're a personal policyholder. So that's some aspect in which insurance is being like or like data science is kind of shaping insurance.
Yeah, I am in the crypto industry. I work for Coinbase. We're a crypto exchange. We make it easy to buy and sell cryptocurrency. And cryptocurrency is basically just new age finance 2.0. So it has just as much an impact in finance 2.0 as it does in finance 1.0, for basically all the same reasons, because we're basically offering the same financial instrument as a regular finance company would, except we're offering them for crypto. So data science is definitely super important. And now I will read the answer from an actual data scientist. Okay, how important is it? Data science is growing from being a role that solves business problems and answers to a role that proactively builds solutions to future problems. Data science team members at Coinbase have led new product launches by finding things that users are interested in, work closely with several business teams and executives. They're often seen as the individuals tying an engineering project to the business needs. This is a big change from doing reports manually and updating data in a database.
When we're hiring for a data scientist, what we do is we give them a problem similar to like a Kaggle competition, where we'll send them some flat files with some information, and we'll have a business problem for them to solve. And very similar to a Kaggle competition, they'll have to make some form of prediction, and then explain that prediction and present it to our team. During the time of their actual submission, we don't know anything about their backgrounds. We don't know if they have a master's. We don't know if they have an undergrad. We don't know their age, their gender, anything like that. And it's purely based off of how good is their code, how good is their model, how good is their prediction, and then how good are they at explaining in written word what they're actually doing. So I think having these technical skills is really paramount, and you're going to see a lot more roles, or when you apply to data science positions, I think you're going to see a lot more of this type of practice where they actually just want you to show the code. Don't worry about the degree as much.
Is have good data structures experience. You need to understand programming very well. You need to be able to give the algorithmic analysis of any basic program just on the fly. You should be able to read it and understand what the analysis is right away. And you should be able to understand why you would pick different data structures. You should be able to explain what the data structures are. Like you probably don't need to know things like red, black trees, but like if you don't know what a heap is, like you're in trouble. So overall, you definitely want to have soft skills, and you need to be able to clearly communicate, and you generally should have at least some charisma if you want to be an effective data scientist. They're absolutely essential if you want to do consulting or management. You need soft skills for those things. If you don't have any soft skills, you do not want to become a data scientist. You want to become some sort of technical person who works by themselves, and coding is the only way you can produce a lot of value in that kind of role, in my opinion. Yeah, as I said, side projects are good only to the extent that you can explain why they're important. You really just want to get as much research experience as you can. networking is super important wherever you go. Like probably the majority of people get jobs with references. You know someone at a company, you say, oh, can you write a reference for me? Or can you fill your internal reference? And that'll make a big difference for employers, just because the odds are that you'll actually have someone in the company look at your resume, look at your application. Whereas if you don't have a reference, there's a good chance they're just going to toss it straight in the dumpster, So networking is really important, but also you can get jobs without networking. Maybe it's 50-50 whether you get a job with or without networking.
Okay, but do you think it's easier to get a job if you network?
Oh, definitely. Yeah, no doubt. Networking is hugely important. And it's not just like saying you met people. There's lots of these networking events. I've seen Josh at them a few times where you just go and you meet, random tech people in the industry and you're like, that's okay. But like really what you need is to like actually have a relationship with somebody. Like it could be someone in your course, you talk about problems together, like if you could talk about a person and say, I know that guy's doing a good job, we should employ him here. Would somebody say that about you? Like that's the question, right? So the quality of the people you're networking with and the quality of the relationship you have with the people is very important. It's not just random people you meet.
I got 3 of my 5 internships through networking, and it works. Yeah, like it is a lot easier to get a job through networking than it is to get one through a job board. Networking is the most underrated skill that you need as any professional, and I highly recommend all of you to get good at that.
That's how I got my job at Coinbase as well.
That's how I got my job at Scotiabank.